Hello everyone, welcome to Engineering and Economy. I'm Dr. Nathan. Today we are going to learn about solar PV cell. People usually ask question like how many cells in a single solar panel. Let's say 250 watt solar panel has how many cells. Why the number of cells is different between different solar panels and between different companies, solar panel manufacturing companies. So in this video you will get the understanding about that. Also, people ask about current rating and voltage rating of a single cell. Also about the entire panel. So why this voltage rating and current rating is different between different companies, panels, those sort of information you can get from this video. Let's go into the video. So if you look at these two panels, you can see that the both panels will provide 150 watts, but number of cells is different. First panel having 60 cells and second panel is having 36 cells. The reason is that each cell has its own current rating and voltage rating, so that is different. Here we have a higher, the size of the cell itself is big and its current rating and voltage rating is different, probably higher than the this side of the cell. So that is the reason. So in simple term, there's no certain rule like how many number of cells in a panel. Let's look at how these cells are connected. As we already learned in last video about the series and parallel combination, each cells are wired in a series connection to obtain a higher voltage. So here 36 individual cells are wired in series. So that is a way your solar module, actually in a technical term, a single solar module having 36 solar cells, each are wired in series. Now that you got a good quick understanding about there's a issue, what happen if one solar cells die or it is not working or it's shading. Because of shading, it is the particular area is not uh, conducting or generating current. The problem, this is why the shading is become a big problem, because if one or few cells are not working, that has huge impact. So that will we will cover in a separate video in the shading impact, how to avoid that. So we'll go ahead with the basic idea today. So look at another diagram here, how they're connecting all each of the solar cells in a series. This is how they are wiring. So you can compare this with the battery, how we wire the battery series to make higher voltage. So 5.5 voltage batteries here, four number of batteries making 6 voltage. Similar to that, if you have 0.5 voltage of single cell, we have about 36 cells. So you can count the number of cells, you will get how many total voltage comes out of this panel. So now we go a little deeper into the idea of a single cell. So this is a single cell. So here we have a bigger size of a solar PV cell, and here have a smaller size of solar PV cell. But look at here, both have, each cells have its own voltage rating, current rating, and power rating. So here, this is a 0.5 voltage and 8.7 ampere. The peak current is 8.7 ampere. But this is the largest size of solar PV cell. Here look at the second one, smaller size of solar PV cells, also having a 0.5 voltage and the current is 5 ampere. So what I wanted to emphasize here, the both larger size of cell and smaller size of cell having a same voltage. So the voltage does not depend on the size of the cell. But the current, definitely the smaller size of the cell having less current rating, 5 ampere. The larger size of the cell having a high current rating, the 8.7 ampere. So definitely the power rating is high for the large size of the cell. So this is understanding you need to get that when you look at the solar PV cell, if you look at the larger size of cell, definitely the current rating is high. But the voltage rating, it doesn't matter about the size. So let's go into this is a very technical thing, like what impact the voltage of the solar PV cell. So voltage output of the solar PV cell is determined by the band gap of the semiconductor material used in the cell. The band gap mean, it's a technical term. In simple understanding, it's we have a n-type and p-type material. Between n-type and p-type material, what is the length, what is the gap between the n-type and p-type material doped in the solar panels. So it is fully related to how the solar cell is manufactured. It's a design idea on the manufacturing side, not on the installation side. It's on the manufacturing aspects. So when sunlight strikes the solar PV cell, it excites the electron in the material, creating the electron hole pair. These electron hole pair generate a voltage difference across the cell, which is known as the open circuit voltage. Okay, so that's how the open circuit voltage comes, because the electron hole pairs are separated into areas. So that's how, quite similar to the battery concept. Okay, so now in a engineering point of view, we need to understand what factors influencing the voltage. For example, if somebody say we have a voltage problem with panel, you have to understand that what are the factors influencing the voltage problem. So one is the material energy level, that is about the band gap and doping related things about the material. You can't do actually anything because it's already manufactured in the factory. It's how they manufacture the panel, how they uh, keep the bandwidth, and how they do the doping. It's based on that. Second is cell temperature. That's one of the key area. If the cell temperature is high, the voltage become low. It means cell temperature, now we are getting hotter and hotter. If let's say cell reaches 50-55 degrees Celsius, your solar panels is reaches 50-55 degrees Celsius, that's is not good for the solar panel performance. So it reduces the voltage. So that's why high temperature is bad for the solar panels. We need the high solar radiations, but we don't want the high solar temperature. Okay, and the design, cell design, how they manufacture the design. Let's go look at into current rating. What are how the current rating is impacting. So current output of the solar cell is determined by the amount of sunlight falling into the cells. So it basically how much sunlight. If you have more sun radiations, then you have a more current. So efficiency of the cell is converting sunlight into electricity. So efficiency, we decide how much sunlight the panel is converting into electricity. Okay, so again, if somebody talking about we have the low current rating, or we have the problem with the current rating on current output of the panel, then we have to understand what are the factors influencing. So it's about size of the cell. As we already said, that if the cell is small size, the current rating is less. And second is quality of the material. Obviously the quality determine the current rating. And presence of any shading obstructions that may reduce the amount of sunlight. So basically when we talk about current problem, current output is low, current related problem, it's quite straightforward. There's a shading issue, because design aspects you can't do much of the things. So it's about shading issue. Okay, look at the next slides, that the last slides. So how to identify, but why we are studying this, because we are not going to manufacture a panel. We are in the user end, we are in the engineering, application oriented engineering. So that's why I always tell to students, like, what you need to know what you had to study. So if you are in the material aspects, you can go and deeper study about the material, but we are not exactly into the material aspects. We are exactly into installing the solar panels and getting output and designing the entire solar system, inverters, battery systems. Okay, so in that aspects, so we study two things: voltage. If there's a problem with the voltage, the probably the root cause is high solar temperature, the panel temperature, cell temperature, obviously cell temperature. And another problem is the material is bad. I mean the material is having a poor band gap. Okay, those kind of things. So two things: if we have a voltage problem, that is a the high solar temperature, cell temperature, or material related issue. If you have a current problem, it's most probably is a shading. Okay, so some solar cells are shading, because of shading issue it's not working properly. So in summary, voltage depends on the temperature of the panel. High temperature gives poor voltage, whereas current depends on the incident solar radiation of the panel. So if you have more solar radiation falling on the panel, we have more current producers. Although size of the cell is matters, but from the application point of view, if you have more solar radiation, we have more current. Okay, that's why the standard test condition we will study in another different video. There's a test condition. Solar cells it has to be kept at particular temperature, that is 25 degrees Celsius. If it is at 25 degrees Celsius, it work well. But if the temperature increases from 25 to 26, 27, 20, 30 degrees Celsius, the voltage will go down, the performance is going down. So that is a the summary end of the this lecture. Please subscribe this channel and provide your support so that I can uh, create uh, many other videos, and it will be really help for you. Thank you very much. See you in next video.